Unlike cable modem connections, Cisco creates equipment that is capable of communicating across the DSL network. So we can move into some of the configuration rather than relying on a cable modem to do the translation for us to an Ethernet connection. So what we're going to look at here is understanding new technologies by configuring PPP over Ethernet DSL connections. This is going to be entirely sitting on a Cisco router. I'm actually going to drive out to a different site that has a DSL PPP over Ethernet configuration and set up their modem, set up their DSL connection, going one step at a time. First off, configuring the dialer interfaces, applying the individual PPP over Ethernet settings and authentication, because most DSL providers won't allow you to get an IP address until you authenticate. Then we'll just go the rest of the way and allow internet access for a small office, home office network. We're going to talk about setting up NAT translations to make that happen, the route to the internet, and get this connection going. Okay, so here we are sitting on a router that is plugged into a DSL connection. Now I want to get you familiar with this router first of all, just to make sure we know where all the interfaces are. Just do a show IP interface brief. Now this is actually, what is this? An I'll do a show version. This is an 870, one of the brand new Cisco 870 routers that have the wireless built into it. So when you see this right here, you're seeing a bridged virtual interface, which is really bridging together the wireless connectivity because it has a built-in wireless access point, and it's bridging the LAN connectivity all into a single subnet. So don't fear the BVI1. It's known as a bridge virtual interface, which bridges LAN and wireless together so that they can operate on the same subnet. Now, you can see that we have Fast Ethernet 0, 1, 2, and 3, which on the 870 series routers are all LAN interfaces because it has a built-in 4-port switch, which is 0, 1, 2, and 3, that allows you to plug in computers. This is designed for a small office network. So that's where those come in. Fast Ethernet 0/4, or I'm thinking modular. Fast Ethernet 4 is actually the WAN interface connection. So there is an inside and an outside set of interfaces. 0 through 3 are inside. Fast Ethernet 0/4 is outside. Now let me start filling in the blanks. Fast Ethernet 0/4 is set up for DHCP, but we're not getting anything because we are plugged into a PPP over Ethernet DSL connection. And in order to get an IP address, we have to authenticate to the connection. So let's make this happen. And we're going to go end to end on this one, get a full working network with this small office router. Forgive me if it sounds a little different than other videos because I am actually at a different site using a different router because I don't have a PPP over Ethernet connection at home. So I'm going into global configuration mode, and one of the first things I need to do for a PPP over Ethernet connection is create a dialer interface. The Cisco router actually interprets the PPP over Ethernet connection as kind of a dial-on-demand connection. It has to go out and speak to the other side on demand and grab an IP address based on a username and password. So I'm going to create interface dialer, and let's go ahead and create interface dialer 1. Now this is an arbitrary number. If you've never configured a dial-on-demand interface before, this number right here is just any number that you want, anything from 0 to 255, as long as it's unique. So I'm in the dialer interface, and the first thing I'm going to do is tell it to get an IP address based on DHCP. With the PPP over Ethernet connection, we do that by typing in IP address followed by negotiated. Now, I should step back and say, wait a sec, it's not quite DHCP because in order to get an IP address, we have to provide authentication credentials. Make sense? So we're not getting an IP address until we give them our username and password, and that is an IP address negotiated. IP address DHCP just means I send out a broadcast and, hello, please give me an IP address. It's not what we're doing here. So I am negotiating with the other side an IP address. I need to also, of course, turn on encapsulation PPP. That tells it use PPP when communicating with the other side. Now this is something that is specific to PPP over Ethernet for efficiency. Watch this. I'll type in IP MTU followed by 1492. Now why am I doing that? The MTU, as you probably know, is the maximum transmission unit. That's how much I can send in a given packet on this interface. And you can see the maximum right here is 1500, which is the maximum defined for Ethernet. Now, if we keep it at 1500, that means it's going to try and shove 1500 bytes of data stuff, including the header, into the packet before it sends it. The problem is that the PPP over Ethernet adds 8 bytes of header information because it now has to carry all the authentication credentials and all that stuff. And if we don't set the MTU to 1492, it becomes less efficient because that 8 bytes puts it above the maximum 1500, so the router will have to start fragmenting, and you're going to start chopping your packets up, never really reaching the maximum transmission unit because you bump it to 1508 bytes when you include the header. So do your router a favor, improve its efficiency, drop it down 8 bytes on the maximum so that it can make room for the header information. Now, I'm going to add a command to this interface since it is the outside. That is IPNAT outside. Here's how this is going to work. I'm going to set up this dialer interface as kind of the logical interface that communicates with the other side. You're going to see, as a matter of fact, I'll do a quick do command, which allows me to do show commands from any mode. I'll do a show IP interface brief at this point, and you can see this interface automatically appeared out of nowhere. Dialer 1, where was it before? We don't know. We just created it when we typed in interface dialer 1. It's going to be the interface that negotiates with the other side. It's going to be applied to Fast Ethernet 4, which is my outside interface. Now the router is going to see Fast Ethernet 0/4 as nothing more than a physical transport. It's saying, hey, I'm going out this interface, but all of my logical stuff is all under dialer 1. So what that means when it negotiates with the other side, guess who gets the IP address? Dialer 1. Fast Ethernet 0/ or Fast Ethernet 4 does not get anything. It's just going to sit there being a physical thing. It's probably still going to send out DHCP requests saying, hey, I need an IP address. Nothing responds because it doesn't have the authentication credentials to get to the other side. So everything is under dialer 1 logically. So what's that mean? When we get to the NAT command that you see right here, it needs to be applied to the dialer interface. The Fast Ethernet interface doesn't need the NAT command because it's not doing any of the IP address stuff. It's not negotiating IP address information. So this is pretty much where all the action is going to happen, is right under this dialer 1. It's the outside NAT interface. Now, my ISP at this location is a little odd. And that is because they use PAP authentication rather than CHAP. Now, I will tell you, in the rest of the world, I'm in Phoenix, Arizona, using, I'll leave the ISP unmentioned because you're probably going to say, they use PAP? You know, who would do that? But they do. So it's clear text all the way. Just about everywhere else I've seen uses CHAP authentication, which is a hashed authentication between both sides. So here's how we're going to set up the authentication. I'm going to say PPP authentication followed by PAP. And this is where, if your ISP uses CHAP, this is where you do it. We use PAP here, not too sure why. I'm going to follow that up with a command that you may not have seen before, and that is call in. The reason I'm doing that is because it's not going to authenticate the other side. By default, when I type in PPP authentication PAP, it does something known as two-way authentication. So it's going to authenticate the other side, and the other side authenticates you. Well, in the DSL world, the ISP doesn't want to be authenticated. They're saying, you're my client, you need to give me the username and password. I'm not going to give you anything. So by putting it to PPP authentication PAP call-in, it's known as a one-way PAP authentication, meaning I'll give my credentials to the other side, but I'm not going to authenticate the other side. I'm not going to require them to give me a username and password. Call-in really says authenticate the remote on an incoming call only. So if the ISP says, hey, I want to call you and get on your network, that's when you ask for the username and password. So this isn't a free ticket for them just to get on in. And the ISP is not going to try to get to your internal network unless there's some really, really odd ISP. So we're not dropping any security by doing that. Now I need to follow it up because I have this little Reebie router here, and I need to follow this up with a PPP username and password for PAP. So I type in PPP PAP followed by sent username. Now you notice it said this little AAA warning. Warning, authentication list default is not defined for PPP. And that's because I said requires some authentication, but it doesn't have anything on this router with credentials. That's going to be because I go under the interface and define it here rather than doing a local user database. So I'm going to type in PPP PAP sent username and then the username that I need to type in. Now I'm going to see, this is a real username and password because this is a real PPP over Ethernet connection. So what I'm going to do here is I'm going to pause the recording, but let me do this. I'm going to type in PPP PAP sent username, and I'll just put mush right there for the outbound username. It is going to ask for a password, and then I type in the password, which I'll just put mush for now. What I'm going to do is I'm going to pause the recording, type in what the real username and password is for this location, clear off the screen, and then come back, knowing that I'm not going to do anything else. I'm just typing this in, but unfortunately, I can't let you see this username and password because it is a real one. All right, I have the username and password typed in there for PAP, and I've wiped the screen clear. There's one more command that I need to type in under this dialer interface, and what that's going to be is dialer pool and a number. I'll go ahead and use 1. What this command will do is tie this dialer logical interface to whatever interface physically I specify. See, what I've done is I've created this imaginary dialer interface. I'll do that show IP interface brief command, and you can see right there it's dialer 1, but it's not really anything until you apply it to a physical interface that can actually carry the traffic for it. So what I need to do is now get out of this dialer interface, and I'll go under interface fast Ethernet 4, which again on this 870 router is the interface that connects to the outside world. Now under this interface, the config is very, very basic. There should be no IP address, and you can see from that show IP interface brief, there absolutely is not. And all I need to do is type in 2 commands. One is PPP over Ethernet enable. You can see there's not much to that syntax, eh? Then I just type in PPP over Ethernet client and associate it with a dialer pool number. Where'd that come from? Right there. I just need to type in dialer pool number 1, and you can see dial on demand. That's if the connection will be severed and go down from time to time. And what that will do is tie the 2 together. Oh, bummer. Oh, no, you're seeing the messages. You can see what's happening in the background. It says the interface virtual 1 is now bound to the profile dialer 1. It created this virtual interface for it, and then the virtual access 1 has gone up. The line protocol went up. And you can see the status messages, but I wanted to turn on some debugs, and I'll do that. I'll shut everything down and do the debugs, but let's just do a show IP interface brief. Look at that. Beauty. We have an IP address on that dialer interface that has negotiated with the other side. Now you can see the methods here. You know, this one came from NVRAM, meaning I statically assigned it when it was set up. You know, this one's trying to negotiate via TFTP. This is DHCP right here. And then we have IPCP. If you think back to your CCNA days when we talk about the PPP protocol architecture, IPCP is the IP control protocol. It's negotiated through the PPP negotiation process. So we've got that IP address on there, but man, I was typing in those commands and I forgot it would just come up like that. We're not done yet, but what I do want to do is turn on some debugs so you can see what's really happening. I'm going to type in, let me exit out here, and I'm going to type in, first off, a show command. Let's do show PPP over Ethernet, and we'll do session. What this does is it shows the established session. You can see a session ID over here, what the remote MAC address and local MAC address is. That's negotiating between both sides, what dialer interface is being used, and so on. And you can see right underneath here that tiny little word, up, which means that it has successfully negotiated the PPP over Ethernet session. That tells us that our kind of the foundation DSL architecture right there is good to go. But we can do debugs. If we're having problems trying to figure out what's happening, what we can do is first off type in debug PPP over Ethernet, and we can just say, show me the events. I can also do a debug, what am I thinking? PPP authentication to make sure that all of that's going okay. Now, we're not going to see anything happening here because it's up. It's already negotiated. So what I'm going to do is get under interface dialer 1 and do a shutdown. And then I'll go under interface fast Ethernet 4 and do a shutdown. I'm killing it all. I'm killing the physical interface and the logical interface. And you can see right here, shutting down the client session, and it gives some of the PPP over Ethernet messages. Now that everything's shut down, I'm going to power it right back up. I'll go ahead and do a no shutdown on the fast Ethernet 4. Now watch the screen, and then go enter dialer 1 and do a no shutdown there. So physical interfaces come up, and now I'll do a no shutdown under the logical interface. Now watch this. We actually have, oh man, I wish I could pause this. We actually have right here the first of the PPP over Ethernet messages. You can see a PADO, which actually stands for PPP over Ethernet Active Discovery Offer, which is the other side. It's the ISP pretty much sending us an offer saying, hey, we've got this information for you right here. And that's at which point the dialer 1 went up. Now, this is a confusing message. It says PPP over Ethernet, we've got our PADO, and the PADO timer just went off. It sounds, I don't know, it just sounds like a funny message. What that really means is it's a unicast reply to us. Now, since we did a shut and a no shut, we didn't get a true complete end-to-end feeling because the session was already established. Typically, oh, you know what? I didn't even see this. I'm insane. Look at this. Sending Patty. Okay, that's the one that I needed. Patty stands for PPP over Ethernet Active Discovery Initiation. I was thinking, how did these PADOs come out without the Patties? And I know, like, as I say this, you're all thinking, yeah, he's a Padawan 1 learner, right? Because we're all Star Wars fans. But Patty actually is the initiation saying, hello, I am a PPP over Ethernet client. Somebody give me an offer. Now this comes back and says, hey, here is your offer. And right there it says, okay, thanks. We've got the PADO. I'm somewhere in between patties of a hamburger and a patio furniture. And the timer went off, meaning that we've got the offer. So from here, the PPP over Ethernet begins to be brought up. Now, right down, it says, okay, we've got the data path. Is this being established? Dialer call direction. It's saying that it's an outbound call. Authorization is not required for this call. In virtual interface goes up right here. This is where the PAP authentication takes place. Now it comes up and says, hey, give me your host name. I'm using the host name from the interface that I typed in, and the ISP saying, give me your password, which is also typed in under the interface. And now you already have half the puzzle right there. That's the username for this location that is being sent. That's the PPP over Ethernet host name that was sent. Now thankfully the debug hides the password, but it was also sent as well. The success message is right here. It says authorization has been acknowledged. If you did not get that, unfortunately, I have not seen in a PPP over Ethernet, if it fails, it doesn't actually say failure of authentication. You just don't receive the acknowledgement. So the authorization acknowledged never comes, and what will happen is this virtual interface access will never come up. As a matter of fact, the dialer interface after this happens will report a state of going back down again. And what's going to happen is it's going to keep cycling. You'll go through this PADO, layer 2 connectivity, and then as soon as the authentication is sent, the dialer interface goes back down. That should tell you that you probably have an invalid username and password. All right, I'm grabbing my chair and screwing up here. I'm sitting back down because this now is a successfully authenticated setup, and now we need to finish configuring the rest of the connection. So let me go ahead and clear all this off because we've got layer 2 and layer 3 connectivity. We've got an IP address. Now let's configure the rest of the connection for this office. In this case, I am going to assume that this office has an internal DHCP server. I'm not going to go on the router and set up a DHCP pool of addresses because the place I'm actually at right now has a Windows 2003 server that's acting as their DHCP server. So besides DHCP, here's what we're going to have to do. I need to set up NAT to translate the addresses coming from the internal network, which is represented by that bridge virtual interface 1, going to the outside network, which is represented by dialer 1. Now we already have IPNAT outside underneath here, so I need to get under interface BVI 1 and type in IPNAT inside to identify that as an internal interface. Now I need to create an extended access list that says what interfaces are valid to be translated. Here we go. IP access list extended, and I'll call this NAT addresses. And what I'll do is I'll permit for the IP protocol, it's not just TCP, not just UDP, it's all TCP IP, from, let's see, the source will be 192.168.1.0 followed by a wildcard mask of 000255, which says that whole internal network is valid to be translated. Translated to where? Anywhere. So anytime they try and access anything outside of their own subnet, they're going to be translated through NAT. And that's all I've got to say about that. That's creating the access list. Now what I need to do is create the NAT entry. I'm going to go in there and type in IPNAT inside source, and we'll say it's defined by an access list. And don't worry, I'm just typing this in, and then I'll come back and translate every single word here. The list is going to be the, what did I name it? NAT addresses. And we are going out interface dialer 1, and we're going to go ahead and overload that connection. Enter. Now let me translate. What this is saying is it's saying, I want a NAT. That's pretty much what IPNAT means. From the inside of my network. Now I'm having a conversation with the router here, right? Let's kind of go behind closed doors. I want a NAT from the inside of the network, and the router asked me, well, what source addresses are really on the inside of the network? Tell me what I'm translating from. I'm going to say, oh, don't worry, router. The source addresses are defined in access list NAT addresses. That's the one I just typed in. So the router goes, well, let me check on that. Okay, it looks like the source addresses are these addresses going to any destination. Now you might be wondering, why couldn't you use a standard access list for that? Couldn't you have just, created a standard because you're just looking for source addresses? And the answer is yeah, I could have. I could have gone in and created a standard access list that just defines source addresses. The reason I didn't is because later on we're going to talk about VPN connections, which means that I can have a virtual private network from one site to another. Well, the thing is if I use a standard access list, that means that I'm translating that source always. And sometimes that may not be so beneficial. For example, maybe I have a VPN from this site, which is 192.168.1, to another site, which maybe is 192.168.2. Well, here's the problem. If we have NAT set up to just grab those addresses and translate them all the time based on source, well, then we're going to NAT them even when they're trying to go across the VPN to the other side, and that's not good because VPNs merge the local area networks. So essentially, later on, I'm going to come back and I'm going to squeeze a deny statement in this NAT addresses here, and I'm going to actually, these access lists, let me type in show access list. These access lists are the new kind. They're sequence numbered. So I can go in and squeeze in entries before this. And what I'm going to do, let me just show you this. I'll squeeze in an entry 5. And by the way, I'm in the wrong mode. I totally understand. I just want to show you the syntax. I'm going to say entry number 5, deny IP 192.168.1.0 with that wildcard mask to 192.168.2.0. with that wildcard mask and squeeze that in before sequence number 10. What that will do is when somebody from this network, which is the 1.0 network, tries to access the 2.0 network, it will not NAT them. It will not just send them out to the internet. It will send them across the VPN as their real address. It won't translate them at all. So That's the scoop on that. That's a sneak preview of VPN stuff. I was having a conversation with the router, was I not? So I'm going to say I want a NAT from the inside of the network that's defined in the source addresses and access list NAT addresses. Now the router's going to ask me, okay, I see the source. Where do you want to send them? And I'm going to say I want to send them out the interface dialer1, and I want to overload that interface so that one IP address is shared among all of the inside addresses. If I forget that overload keyword, only one address will be able to translate out, and then nobody else can translate anymore because we're not using PAT or overloading that interface. So the other thing I want to mention is interface dialer 1. Now, some of you may remember, if you think back to NAT and how it's set up, that normally you point it from a source list to a pool of outside addresses. And you create your NAT pool and type in the addresses that the ISP gives you, and you can translate out. Why'd you point it to the interface? Well, I don't know if you noticed, but that interface right here was assigned dynamically. This site does not have a static IP address, so if I were to tie it specifically to a pool of addresses, even if I typed in this address as the pool, just a pool of one, and that address changed, well, then my NAT would fail. So instead, putting interface dialer 1 there allows me to translate out that interface, whatever IP address is assigned to it. The router fills in the blank. It says, oh, well, let me check what IP address is there. Oh, right now it's this? Okay, well, let me send you out that IP address. That, by the way, is a handy command for any of you that use a Cisco device at home and you have a dynamically assigned IP address. It's not just a DSL thing. I mean, cable modem service providers, DSL, of course, service providers, satellite internet, all of those dynamically assigned IP addresses. This allows you to use NAT with a DHCP assigned address. So we're almost done. One more command, right? I need to go here and I need to tell this router how to get out. Watch this. I'll do a show IP route, and you can see as of right now, the only thing it knows about is the internal network and what it's directly connected to. That's dialer 1. So that's the external WAN. But we're going to be going all over the world. We need a default route. So here's how I'm going to do this. I'm going to type in IP route 0.0.0.0, 0.0.0.0. That's my default route. And I'm not going to send it to a next hop IP address. I'm going to send it out the interface dialer 1. So now I go back and do my show IP route, and I can see I have my default route sending everything out dialer 1. You ready to see if this works? I'm going to type in ping 4.2.2.2. That's my favorite IP address in the world. It's a public DNS server. If you ever need a DNS server, there it is. It's run by a university, and they allow ICMP ping messages, so it works great for testing. I know if I can't ping it, it's always up, so I know something's wrong on my end. I hit enter. Oh, that's beautiful. So we have, at this point, configured a complete PPP over Ethernet connection, negotiated the IP address with the other side, set up NAT, set up the default route to get out. This office is good to go. It's got the stamp of approval. The inside clients will now be able to access the internet. And that was almost my conclusion right there. That's all the pieces that had to come together. The dialer interface, applying the PPP over Ethernet settings to the physical interface, adding in the authentication to, in this case, it was PAP authentication to the ISP, and then finally setting up the NAT and static routing to allow the office to communicate to the internet. I hope this has been informative for you, and I'd like to thank you for viewing.